The Surgeons General. That was Lisa. I didn't go. Oh, you said no. Oh, okay. Somebody else did. Shit. It was like, it's just got in there, and then about an hour in, like the mosh pit was like really I honestly like the outside of usually that's not my like in the middle, right? So then I have to do the outside. It's not really like really too much. I just want to just a notch a little. So I me and my buddies yeah. Oh yeah. As soon as we walked out, a bunch of guys came out, and I was talking to them earlier. They seemed like really chill dudes, and all of a sudden, like, it's like, but like, I was trying to sit for a while, so like, I just and everything. Totally cool. Everything like that's the get back into the everybody so everyone was in the back of mind. They were literally picking up saying like that's or you can go back inside. We didn't go back so like sorry that is it was right now but then it wasn't that bad until the night and then like the rest of the night we just like there's no deep I can't believe it's test. It was hard, but yeah. I just like better next thing. So I just have to start last time was crazy. I got like yeah, it's pretty much it's like 10% like and like put it this way. Almost no, I think I might have. I mean, very into the You're supposed to guess it.
Oh, I knew that.
It was broken down. I was like, oh fuck.
Hi everybody. How's it going? Wow, such a full class today. Man. So last time we started talking about design. So we covered coupling and cohesion, which was the lecture lab. So you had 3 days to do the lecture lab. So what we'll do today is actually just go ahead and review the lecture lab. So the solution has been posted to the schedule. Okay, so that will be the first thing that we'll do, is review coupling and cohesion. And then the rest of the time we'll talk about design patterns. And really, if you think about the course, then all of these topics, this is kind of the, the last topics covered by 210. So this is all we'll do in the rest of this term, right? Is we're going to talk about design, essentially, and design patterns. Because towards the end, we're going to have a review session. So for the final, it's going to be on Friday, I think. And so the review session will be on Wednesday. So we'll use a lecture for that. And then for each of these design patterns, we're going to have lecture labs so that you get to practice them. So today, we're going to talk a lot about the observer pattern. So concerning the project, Waldo, you should be, by the end of this week, you should be really somewhere around task 4 to 6 or so, right? If you're not up to task 4 or 6, you should be concerned slightly. If you haven't started, you should be very concerned. It's going to take you a lot of work to catch up. We're going to have a Java tutorial. So this was posted on Piazza. We've seen that people are struggling with some kind of basic Java concepts, perhaps. So if you're one of those people, you should go to the tutorial. It's not going to be taught by me or Gail. It's going to be a TA. So we're not going to know that you're at the tutorial. You should go and catch up on it. And it's going to run 5 to 6 p.m. And we don't have a room for it yet. So we don't know exactly when, exactly where it's going to happen or whether it's going to be video recorded. Hopefully it'll be in this room. And hopefully the TAs teaching it will be okay with recording it. In that case, you'll be able to find it online as well. And then there was this poll on Piazza about using computers for the final exam. If you haven't voted yet, you should. We're trying to figure out exactly what the final exam will look like since it's coming up relatively soon. So if you have any strong feelings about whether you want to use computers or not, you should go ahead and vote. As you can see right now, it's sort of split, so can't quite tell what you guys prefer. Yeah, any questions so far? Yeah.
Can you scroll down some tiny bit to see what the abstract question is? Yeah.
Oh, yeah. So the question is whether having computers or not having computers implies more difficulty or less difficulty. My take on it is that really depends on the person. Gail's take on it is that the exam will be the same either way. Yeah, I think it really depends on you guys and depends on how fluent you are with Eclipse and computer tools, right? So if you type really fast, if you know Eclipse inside and out and all the shortcuts, you'll probably have an advantage, right? If you really struggle with Eclipse, if it's overwhelming, if you don't like seeing 100 class files and browsing through them, maybe you won't do so well, So think about this question and do vote. Your vote counts. Great. So today we're going to talk about design and in particular the observer pattern. So all of these patterns are documented in this fantastic book called Design Patterns, and it's sort of a really foundational book in software engineering, and it's heavily cited, and it covers a lot of different design patterns, which is what we're going to be talking about. So the reason you need to know about this is because, well, if you're going to apply for a software engineering position or co-op, they're going to probably quiz you about design patterns. They're going to ask you about some. So they may ask you to name one or describe one or name your favorite one or something like that. So you should have at least a clue of what they're talking about. Another reason you should know about these is because they're very influential. There's this book came out about maybe 20 years ago now. And since then, it's had a lot of impact on the field. And there's a lot of different kinds of design patterns. So here's kind of the outline of all of them. Creation patterns, structural patterns, behavior patterns. There's like 15, 20 in here. So in the course, we're only going to cover 3, right? So there's a few that are commonly used, and those are the ones we'll look at. There's a bunch of other ones, and you don't have to know them. It would be great if you know about them. I personally don't know all of them, so you certainly don't need to know all of them. The reason design patterns have had such a good influence is because if you think about software, usually the way you build it is the way you would design and build a building, right? So you would have some foundation, you'd have some doors, you'd have some windows, You want to have some bathrooms, right? So there's a lot of elements that are very common to all buildings. A lot of elements that are common to all software, right? Even though we're dealing with abstractions and we might be representing different things, right? We might be representing a course of students, we might be representing a Space Invaders game. You know, the kinds of relationships between those objects that you want to capture in your code will be very similar from one project to another. So just like with buildings, you know, there's certain design patterns that you use in architecture. You know, there's certain design patterns that you use in software design. So the pattern that we'll look at today is called the observer pattern. And I'll just show you what it looks like in the book. So essentially in the book, you know, there's a chapter for each pattern. And for every pattern, you have some kind of intent, right? So for the observer pattern, the intent is to say that you want to define a one-to-many dependency relation between objects so that one object changes state, all of its dependents are notified and updated automatically. And it has some names, motivation, and then you know, now that you know UML, there's actually a UML class diagram down below that actually tells you what would be one potential realization of this pattern, right? Like, how would you implement this in code? And of course, the book talks about patterns, so it's not tied to any specific language. So one way of representing that pattern would be with a class diagram, right? That would capture the relationships you want in your code without specifically saying this is Java or C++ or whatever else. And then you have the beautiful sequence diagrams as well in the book that talk about, this is hard to show, that talk about how you would actually, you know, what would be the possible control flow within your system if you were to use such a pattern. So this book kind of goes through all of these, right? And so we're going to talk about 3 of them: the observer pattern, composite pattern, and the iterator abstraction. And to show you to motivate the observer pattern, I'll use this really simple example of a spreadsheet. So here we have a spreadsheet that talks about, you know, you have these different operating systems and you have some number of people who use them, right? And then I have this data, and then I want to represent this data visually, so I created these graphs down below. And I may have multiple representations for the data, right? So Windows, well, Windows is super popular. How many people use Windows? Great, a lot of people, like 100 people. What about Mac? Mostly in the back for some reason. All right. Chrome? Anyone using Chrome?
Oh, like the browser or
The operating system. Okay, that's like 0 people, right? Okay, and then Linux? Linux people. Great. Okay, that's like, 2 people. I thought it was 20, but. So, well, as you can see, there's 2 dominant operating systems here. But the key observation from these graphs, right, is that every time I change a value in my spreadsheet, my graphs change as well. So if all of a sudden in a different class, number of Chrome users goes up, you know, if it's 50, you know, then all of a sudden all of these plots change, right? I changed my value in my spreadsheet, and that change propagated to my graphs. So the reason this is an observer pattern is because, in a sense, these objects, which are graphs here, are observing the changes that I made to the spreadsheet. Okay? So this is the observable, you know, object or observable state. And then these are the observers. There's 3 right now. I could add 1 more. So this is a very common pattern in software engineering where you have some data. This is a very simple one. You have a spreadsheet. And whenever you make a change to that data, you'd like that change to propagate to all of the observers who are interested in that data. So I might have another cell, which might be here, you know, and might have some data here. But whenever I change these values, you know, the changes are not propagated to my observers. Because, in a sense, this data has no one who's interested in it. Right? No observers are watching this data. So I have to explicitly say that there's a relationship between the data that is here and the observers who are interested in it. So that's kind of as a motivation, this is the observer pattern realized in a spreadsheet form. So what it looks like in the UML diagram is that you have some subject class. And my subject class on the left is really my spreadsheet. Right? My subject class has some state. And we also call this thing the observable. And then there's going to be some number of observers. And the relationship between these is unidirectional. So a subject might know about 0 or more observers. And as another kind of piece to this puzzle, the observer needs some kind of method, which you can think of as a callback in event-based programming, which is typically something like update. And update is a method, and sometimes you can pass something into that method. So the way to think about this is that I have some subject. The subject knows about multiple observers. When the subject changes state, it invokes the update method on all of the observers who are interested in the subject. So this is kind of the abstract representation. So down below, you might have something more concrete. So if this was an abstract class, then it might be extended by some concrete subject. And the observer might be an interface or a class. Let's say it's an interface. So it might be implemented by some concrete observer. We can just say graph or bar graph. And maybe the concrete subject here is cell, like in a spreadsheet. And so what we have now is the cell is going to subclass subject. And whenever its state changes, internally it's going to invoke the update. But the update is going to be on the observer object that it knows about. Right? And since it's subclassed by bar graph will have an update method. And the update method here might do something like, like change height of bar, heights of bars. So in a sense, the update will propagate to my concrete observer, which in this case is the bar graph. And the cool thing about this pattern is that the subject, which is the cell in this case, only knows about observers. It doesn't know about bar graphs. It doesn't know about line graphs. It doesn't know that there's all these kinds of graphs that I have in my system. So if I want to add a new graph to my system, right, all I do is I say, well, I'm now going to create a new class. It's going to implement observer, and I'm going to call it line graph. And when you call update on the line graph, it's going to do something else. Right? It's going to move lines, or it's going to change color. That's up to the line graph. But the key thing here is that the cell doesn't know about line graphs. The cell only knows about observer instances. Okay? So for today's lecture, you should check out 2 projects. The first of these is going to be alarm system. And the second one is going to be Space Invaders Refactored. So you probably have all of these already. So Space Invaders Refactored, we're actually going to do a lecture lab towards the end using that project. And then we're going to use Alarm System to just give you an illustration of what this observer pattern looks like in code. Right? I drew these diagrams, I drew these boxes, but now the question is, okay, how do I actually represent that pattern in my code base? So check out Alarm System. And let's look at the alarm system. So I can run this thing, and I can show you what it does. So here's my alarm controller UI. So here's my system. It's kind of complicated. There's a lot of stuff in here. But basically, the idea is you're going to arm the system. So I'll use some code like 1111, and it's going to hide it from me. I'll add the code. I'll add a sensor, like a door sensor. I will arm the alarm. And when I close the door, my alarm will fire. And my control panel is now aware that there's an alarm going on, so it'll ring visually. So that's kind of the system. And the system uses internally this observer pattern. So if you look inside the model package, you'll see that there's an observer class, there's an interface observer, and there's an observable abstract class. So an observer, right, just like in the diagrams, an observer is an interface, and it defines just a single method, which is the update method. Now, this update method is actually going to carry with it a little bit of information. And this is the Boolean that will be passed to the observer. So this will tell the observer whether the alarm is ringing at the moment or not. Okay, so I'm notifying the observers about an alarm state, and I'm telling them whether the alarm is ringing or, is it not ringing. And then the observable class is an abstract class, and it knows about a few observers, right? So I just keep a list of these guys. I'll initialize the list in my constructor, and then I can add an observer if you are interested in having one more object that wants to be notified about state changes. Or you can notify observers. Right? So then observable is actually subclass by alarm. So alarm extends observable. Right? So I can actually draw a similar diagram that looks just like this thing, but for the alarm system. So we had observer and observable. So observer is an interface. So I have interface observer. And my observer has an update method. And then I have observable. I switched them, didn't I? Sorry. Should I draw it on the other side, or are you guys okay with that? I swapped them, right? Okay. And then I have observable, which is an abstract class. So I'll draw it on the right. Right. And observable knows about multiple observers, right? So this is my association relationship, where there's a list of observers. I have 0.n. So right now it looks very similar to what we had before. And then I have a method for adding observers, and I have a method for notifying observers. Right, so I can add observer, and I can notify observers. And notify here acts very much like update did, right? In a sense, it's a way for me to notify all of my observers. We didn't see it in the other diagram, but it's very much update as the receiver of this notify observers. Okay? Okay, so then we're looking at observable and would say, okay, so who uses observable? So references are an alarm. So my alarm class extends observable. So my observable abstract class is extended by my alarm class. And so it extends observable so we can look at what does it actually do with the observers. So one class that it fills in for us, right, it overrides notify observers. So if you were to look at observable, observable has an abstract method, notify observers, and then alarm implements this method. So alarm actually fills in the details for notify observers. Right, so this is made concrete. And to implement this method, what does it do? It iterates across all of the observers. Right, observers is my list of observers. And on each one it says, okay, you, observer, listen up, I have a change in my state. And it does this by calling the update method. And it passes in the little bit of information, which is sounding. Right? So it doesn't know who these observers are. They could be arbitrary objects that are implementing the observer interface. Right? We don't know who they are. So it's really easy to add a new observer to the system. Right? Because you just need to implement this interface. It's really trivial. And my alarm system is not going to know about you. Of course, these observers, somewhere these observers need to be added to, right? So observers right now, initially it's empty. So who exactly are these observers who are observing the alarm? So if you look in the alarm controller, it knows about the alarm. And the alarm so, the alarm controller is going to check whether it's sounding, it's going to silence it, it's going to do a bunch of things. But one of the cool things here is that the alarm controller is going to add observers to the alarm. So it has this little method here, add alarm observer. And you can see where it's being called from. And it's being called from add display panel and alarm controller UI. So here's where I add two observers to my system, my alarm UI and alarm siren. So if I look at these, they must implement the observer interface, right? So alarm UI implements observer. So that means in my diagram, I have an implements relationship for my alarm UI. And so if it implements this interface, it must implement the update method. So if I look at the outline, my update method here simply changes my alarm UI, changes the color from red to green. So I have a class alarm UI. It has an update method. Right, and this guy simply changes color from red to green plus back. And then the alarm controller adds another observer, which is the alarm siren. So if I look at the alarm siren, very similar, right? Implements the observer. So here's one more observer. My alarm siren. Must also have an update method. And its update method is going to probably set the position of some frame, which is a clip. Yeah, it probably plays some sound, right? That's what an alarm siren does. So play siren. Okay? So we've essentially reconstructed, we've extracted this class diagram from the code. And notice that it's very similar to the pattern that we started with, right? So you can't see it, but here it is. We had the subject, we had the observer. Here we have the observer and the observable, right? So flip. So in the system, it's now easy to extend it, right? So if I wanted to have another class that listened to alarm notifications, what would I need to do according to this class diagram? How would I change my system? So if I wanted another observer, well, what do I need to do? Let's say I wanted to add, I'm going to add a little class that's going to print out to the console whenever there's an alarm. Yeah.
So you implement the observer interface, and
Oh.
then you override the update method with the interface.
Right. So I will implement the observer interface. I'll add one more for edge. I'll say alarm printer. And then, like you said, I'll implement an update method. Now my update method will print alarm to console. Is this sufficient? What else do I need to do to make sure that updates actually reach the alarm printer? Lucas? That's right. I have a list of observers, right, in my alarm. And the list of observers, I need to add an observer. Add a new observer. And that new observer is going to be my alarm printer. Right? So let's try to do this. So here's my project. I'm going to add a new class. Maybe I'll add it to, maybe it's a UI element. So I'll create a new class. And I'll call it alarm printer. Ooh, I spelled it. Maybe I'll rename it to have a lowercase r. So my public class alarm printer, it needs to implement this interface, right? So it will implement my observer. I need to import my observer. Oops, not this one. Implement my observer in my project. And then now this class needs to implement all of the methods. So I have an update method. And so in the update method, I'll simply say system.out.println. Maybe I'll do new alarm state is right? Something like this. So this now observes anytime my alarm changes, right? And it's just going to print something out to the console. But this is not enough. I have to make sure that this observer is known to my alarm class. So somewhere in my alarm class, I need to make sure that I add a new observer. Actually, alarm controller. So my alarm controller, somewhere it adds a bunch of observers. So I'll just do that here. Right, so I have an alarm controller, and I will add an alarm observer. I'll create a new alarm printer. And hopefully that's all I need to do, right? So very simple. right? I need a class that responds to alarms. And so what I did is I added a new class, and I implemented some functionality here to handle alarms. And now this guy knows about alarm printer and passes, passes notifications every time there's an alarm. So run this guy again. And my alarm, of course, is going to sound when I activate some sensor. So I'll create a new sensor, my window. I will arm my system. I will close my window. Now my alarm is ringing. So if I look in the console, here it is. New alarm status true. Right? And now if I don't know, maybe system's not ready. Maybe if I disarm the system. Oh, I have to probably provide the code, disarm the system. And now my alarm state is false. Right, so I received 2 notifications in my alarm printer class that I just added. And the cool thing here is that I didn't have to orchestrate that whole notification process. It just kind of happened for me. Because I knew exactly where in the system I need to make my changes. Right? I literally added like 4 lines of code to the entire system. And now I have this new capability. So I didn't need to understand how this path actually works. I just needed to know where to add the observer, and I needed to implement the observer. Okay? So that's really the power of this pattern. So now it's your turn to practice this thing. So there's a lecture lab posted online, but here's the text. So your task is to check out the Space Invaders Refactored project, and then add new functionality using the observer pattern. Okay, go for it.
No, you're not ready yet. No, we do. Yeah. I got peer review. Shitty comments. Well, that's what I'm saying. 2 out of 5. So now we do the study is relevant. Like I know for a fact the study makes perfect sense. It's dumb because it's like I don't think anybody should ask me my opinion for a sentence. I don't know shit. assume that's how it is for all the other free series. So to help them determine. Oh no! I'm falling over 80% like I got marked. Which is kind of sucks. I got like 70%. I hate that, and especially because like sometimes you're like, oh, you get your first one, like the perfect one, and the last one, it's giving you like 1 out of 10. I'm like, well, okay. But I think I lost like 50% on EP format. I had the wrong font. Only ever right just like it's on forms on skills. I never really saw it. I did that in high school. So I had a crazy.
So one thing I forgot to add to you guys. Let me switch this over really quick. The one thing I forgot to add is that you're supposed to, in the description of the lecture lab, you're supposed to use the Java API for observable and observer. So this pattern is so common, right, that Java actually has these classes interfaces as part of the Java standard library. So if you just Google for observable Java, then you'll get observable, on first hit. And so these classes are part of Java. That means you don't have to create new classes in your Space Invaders refactor. Right? You reuse these classes that are already part of the Java API. They look slightly different, and you have to read them carefully. But here you have the observable, and it's a class. And so an observable can add an observer, right? And then observer class is an interface. So if you have an observer, then you're going to implement this interface, and it needs to implement the update function, just as before. Okay? So just Google for observer and observable Java API, and then you'll find these classes. And these are the ones that you should use in your project, in the Space Invaders refactor. Is observable a class? Right. I don't know. Look it up on Java. I mean, if it's a class, then you can only extend it. You can't you can actually. So, I mean, look it up online. There's a observable class. I always forget. Observable is a class, so you can add it. You can extend it. Because then you can add extensions. Probably.
take that too much over. No, I think some it's pawns, my first year stuff, and it's just like, I got a friend, Christine. Yeah, that's the, I remember, that's what we were saying in the coast. She's in my crew, That's funny, that was weird. Science. Yeah, the computer science was we do computer science. Wait, it says 210 or 211? I took this course last It's so bad. It's so easy. It doesn't. There's no final. One midterm. It's a poster project for the final. I'm taking Site 1 and 2. Definitely gonna be harder than not doing it. They're gonna do that really well. I'm just so nervous. Do stuff with the instructor. I didn't know that. The stuff that I didn't know threw me off. The stuff that I didn't know, and it just like looked at me. I was checking, and then I saw the 20. That's so good. I get fucking stoked. And I'm like, wait, shit, that counted out. Like, divided by 8.
Okay, so we're going to go over the solution. We're going to go over the solution on Friday. But the key thing here is to think about what what is the observer and what is the observable. Right? So in order for you to implement this thing, you have to say that there's going to be some observer class. Well, the observer and the observable are part of Java Standard Library, right? But you're going to implement and subclass these guys, and you want some class to be here and some class to be here, right? And you have to figure out what those classes should be. And then the second step is to make sure that the notification actually flows from the observer to the observable, right? So you have to make sure that you add that notification somewhere else in your code. So there's really 2 steps, okay? So think about that, and we'll come back to it. on Friday.
I felt bad. People were watching, like, we never heard about it, but what if he was just like,
You should send me an email. Yeah, send me an email. Do you have a question like you think it's incorrect or? Yeah, send me an email. Yeah, absolutely. Hey, Lucas. Let me look. All right. What's up? It's okay.
so let's just go.